In this video, we shall show how to solve a system of nonlinear equations by elimination. Last time we did it by substitution. Okay, so we shall go straight to exercise 1.22, elimination method. Solve the system, number 10. So this is our system. Again, how do you write a system? You enclose or you group your equations using your brace. These are curves. These are second degree equations, and these are curves. These are among the curves in your conic sections. Can you guess what they are? Well, obviously they are not written in standard form. So in order to write this in standard form, this one must be equal to 1. How do we do that? We divide it by 16. And this one is actually a hyperbola, but it's not written in standard form. To write it in standard form, we divide it by 5 so that this becomes 1. Okay, so let us show our equations when they are in standard form. Alright, so we are not yet done, because in our standard form, the coefficient of x squared in the numerator must be 1. The same with y squared. The same with x squared here and y squared here in our hyperbola. Okay, so how do we write it? 3 over 16 is the same as 1 over 16 over 3. And 4 over 16, there's a common factor here, 4. So you cancel 4. What is left in your denominator is 4. The same with your hyperbola. How do you write this in standard form? The hyperbola. So 2 over 5 is 1 over 5 over 2. Okay, so 1 over 5 over 2. So this is your a squared. And this one is your b squared. So our system is a system of two conic sections. One is an ellipse and one is a hyperbola. We shall solve this system. We shall do it by elimination method. Okay, you have done elimination method in the past. I mean, solving systems of linear equations was introduced to you way back in grade 9, grade 10. So, I will not explain every bit of step involved in the elimination method. So, this is what I'm going to do. I will multiply the first equation by 3 and the second equation by 4. Okay, look at what happens. If I were to multiply the first equation by 3, so this becomes 9x squared. This one becomes 12y squared. 3 times 4 is 12. And 16 times 3 is 48. How about the second equation? I will multiply it by 4. Okay, so this one becomes 4 times 2 is 8. This one becomes negative 12y squared, and 4 times 5 is 20. I will now add the two equations. And after adding them, you will now understand why I multiply the first by 3 and the second by 4. You add similar terms. 9x squared plus 8x squared is 17x squared. Positive 12y squared plus negative 12y squared is 0. And 48 plus 20 is 68. So you know now why I had to multiply the first by 3 and the second equation by 4, because I want to eliminate y squared. I want to eliminate y squared, so I have now one equation in one unknown. That is the direction of your method, to produce one equation in one unknown. So solving for x squared is 68 over 17. X is plus or minus 2. So it's our turn now to solve for y. So we will just do it by substitution. Let us pick the second equation. You can use any of the two. So when x is 2, 2 times 2 squared. Okay, so this one came from this. One of the equations in your system. Minus 3y squared is equal to 5. So y squared, simplify it. Y squared is equal to 1. Y is equal to plus or minus 1. What if x is equal to negative 2? So when x is equal to negative 2, again, you substitute and you obtain the same thing. When x is negative 2, y is equal to plus or minus 1. So let us write our solution set. You should be careful when writing your solution set. So when x is 2, y is 1 or negative 1. Those pairs of points are this: 2, 1, 2, negative 1. When x is negative 2, y is either 1, positive 1, or negative 1. So these are the elements of your solution set. Your solution set contains 4 pairs of x and y. Again, our geometric interpretation of the solution is these are the points of intersection. And the only way we can be sure that they are indeed the points of intersection of your curves, this one is an ellipse, this one is a hyperbola, the only way to see their intersection is by graphing them. Okay, so this one is an ellipse. This one is a hyperbola. Those are their intersections. Okay, and you can match each of them with the elements of our solution set. So we got it right. We got it right.